Okay, so with the compound interest formula, there's a K in there where you can compound daily, monthly, yearly. You can put in, how many times you're compounding interest per year, and that changes the result. And a mathematician a long time ago decided, like, hey, instead of trying to compound monthly and daily, why don't we just compound an infinite amount of times per year? We compound every instantaneous moment. Okay, instead of doing compounding interest every second or every millisecond, it's using calculus, the limit as the number of periods k goes to infinity. Okay, and what they did was they came up with that number e. So that's the origins of that number. I guess maybe you didn't come to this video to hear about the origins of that number, but this gave rise to the compound interest formula, the compounding continuously formula. Okay, that's what this is. So P is the amount of money you start with. It's usually A, I guess, is the amount of money you end with. E is a number. It's 2.7 blah, blah, blah on your calculator. It's like pi. R is the percentage as a decimal, and T is the time in years. So they want to find out when it triples in value. They didn't give us any dollars here, so we can just say it's $1 starting for P, and we want to end up with $3 for A. Okay, so we got to solve for T. It's in the exponent position. So use a logarithm to get a variable down. Take a logarithm of both sides, and remember that notation is not ln times 3, okay? That's the natural log. 0.0575t. And the whole reason we did this is because there's a property of logarithms that says any exponent inside your argument can come down and multiply, and now it's not in the exponent position anymore. Now we can solve for t. Oh, and I kind of I went a little bit too far with this, okay? Because a natural log of an exponent base e, those are inverses of each other. Natural log e, go ahead and natural log e, go ahead and punch in your calculator. It's 1. So forget about it. That's why choosing natural log instead of log is a good choice for this problem instead of common log. All you have to do is divide both sides by 0.0575. So we're going to do natural log 3 divided by 0.0575, so that's 19.1, so about a little over 19 years is the answer.